Hello students, in this video we are going to see Unit 2 Motion. Today our learning objectives are uniform circular motion, centripetal acceleration and centripetal force, and finally centrifugal force. First we are going to see uniform circular motion. First we are going to do one activity. Take a piece of thread and tie a small stone at one of its ends. Rotate the stone to describe a circular path with constant speed by holding the thread at the other end. Now you release the thread and let the stone go. Can you tell the direction in which the stone moves after it is released? If you carefully observe on being released, the stone moves along a straight line tangential to the circular path. This is because once the stone is released, it continues to move along the direction it has been moving at that instant. This shows that the direction of motion changes at every point when the stone was moving along the circular path. When an object is moving with a constant speed along a circular path, the velocity changes due to the change in direction. Hence, it is an accelerated motion. For example, revolution of Earth around the Sun, revolution of Moon around the Earth, and the tip of the seconds hand of a clock are all accelerated motion. If an object moving along a circular path of radius r takes time t, the come back to its starting position, then the speed v is given by speed is equal to circumference divided by time taken. That is, we can written as v is equal to 2pr divided by t. Next we are going to see centripetal acceleration and centripetal force. A body is said to be accelerated if the velocity of the body changes either in magnitude or in direction. So, the motion of a stone in circular path with constant speed and continuous change of direction is an accelerated motion. In this case, there must be an acceleration acting along the string directed inwards, which makes the stone to move in a circular path. That's why this is a centripetal acceleration. This acceleration is known as centripetal acceleration and the force is known as centripetal force. Since the centripetal acceleration is directed radially towards the center of the circle. Here the image of centripetal acceleration and the centripetal force. The centripetal force must act on the object radially towards the center. Let us consider an object of mass m moving along a circular path of radius r with a velocity v. Its centripetal acceleration is given by a is equal to v square divided by r. Here a is a centripetal acceleration, v is a velocity and r is a radius. The magnitude of centripetal force is F is equal to mass into centripetal acceleration. We can written as F is equal to mv squared divided by r because F is equal to mass. We have written as m and then centripetal acceleration. We have the centripetal acceleration value v squared divided by r. That's why F is equal to m squared divided by r. And finally, we are going to see centrifugal force. Again, we are going to do one activity. Take a piece of rope and tie a small stone at one end. Hold the other end of the rope and rotate it such that the stone follows a circular path. Do you experience any pull or push in your hand? In this activity, a pulling force that acts away from the center is experienced. This is called as a centrifugal force. Yes, pulling force that acts away from the center is experienced. This is called as a centrifugal force. Force acting on a body away from the center of circular path is called centrifugal force. The centrifugal force acts in a direction which is opposite to the direction of centripetal force. Its magnitude is same as that of centripetal force. The dryer in a washing machine is an example for the applications of centrifugal force. In this, do you know, we have the example of centripetal force and centrifugal force. Any force like gravitational force, frictional force, magnetic force, electrostatic force may act as a centripetal force. At the same time, when you go for a ride in a merry-go-round in amusement parks, you will experience an outward pull as merry-go-round rotates about vertical axis. This is due to centrifugal force. Okay, students, thank you. We will meet the next session.